Yes, sir.
Alright, before we start, we just gotta let you know what stuff is. Mouth, stomach, liver, gallbladder, pancreas. Okay?
Yes, sir.
So, as we eat carbs, carbohydrates are very complex, I'd like to say. They're simple carbs, complex carbs, okay? They look mainly like this. If you break them down to a molecular level, they have 6 carbon, 12 hydrogen, I'm pretty sure, and 6 oxygen. It's complex. So you have to know 6, 12, 6. Just know 6, 12, 6. But when we're eating them, they look something like this. They look boom, 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 connected to boom, 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 boom. Something like this. Okay, look something like this. Now, when we eat carbs, there are 2 kinds of carbs. There's alpha carbs, and now there's beta carbs. So, how do we know which one we have? Well, in our salivary glands, we release salivary amylase. Which kind of amylase? We release alpha amylase, which means we can only break down alpha carbs. So, when we eat carbs, it doesn't stop only alpha, there's alpha and beta. Beta, since we can't absorb it, is known as fiber. It's very essential, helps us poop, very good for the system. We can't absorb it, but it's good for digestion. So, when we eat, and we're talking about absorption, we're talking about alpha carbs, breaking down by alpha amylase. So, salivary glands release the enzyme amylase, okay? Amylase, all it does, it's not very strong, it's not very potent because it's in the mouth. And what that does is it just tries and cuts the carbs. Doesn't do much, but it does assist and it makes them smaller. By the time it gets to the stomach, nothing really happens in the stomach. You just have to know that since food is entering the stomach, the movement of the stomach, food entering the stomach, and the pH level of the carbohydrates entering the stomach can activate G cells. And G cells release gastrin, and what gastrin can do, gastrin enables the parietal cells to release hydrochloric acid, and it also activates chief cells to release pepsinogen. But since none of those enzymes really assist in anything, we don't have to worry about that. The only thing we have to know about is hydrochloric acid. Hydrochloric acid is very acidic. Once it enters the stomach, and now since it's in contact with the carbohydrates are now very, very acidic. The pH is around 1 to 2, and this plays a very crucial role. As it enters the duodenum from the stomach, the pH activates the S cells and the I cells. So what the S cells release, they release secretin. And what secretin does is it basically tells the liver and the pancreas to release bicarbonate. Why is bicarbonate very important? Well, if we need to get the pH level back to what it has to be, we have to release bicarbonate. So since bicarbonate is being released from the pancreas and being released from the liver, all it does is it raises the pH from 1 to 2 from the hydrochloric acid back up to 7 or 8. And 7 or 8 is when most digestive enzymes work the best.
Why does it need to be back up? Why can't we just have...
Well, you see, Billy, that if the enzymes, or if the duodenum is very acidic, and it's not in the stomach where it's supposed to be, it can actually burn our duodenum, which is not good. We can have ulcers in our duodenum, and that's no bueno. Also, raising the pH makes the digestive enzymes work the best.
Oh.
So now that this is an S cell, okay? S cell, and an S cell release serotonin
Secretin?
or secretin. Yeah, and you have to know secretin tells the pancreas and liver to release bicarbonate to raise the pH level, and secretin also tells the liver to make more bile. It doesn't tell it to secrete, it just tells the liver to make more bile. Now, also from the carbohydrates entering the duodenum, we have another cell. This is called an I cell. Now, what I cells release is they release CCK. Why is that important? Well, CCK tells the pancreas to release more pancreatic juices. In the pancreas, there are three major enzymes, okay? In the pancreas, we got lipase, we got amylase, and we got trypsin. Lipase are for fats, trypsin are for proteins, and amylase are for carbohydrates. So, CCK being activated by eye cells, or released by eye cells, tells the pancreas to release more enzymes. And the enzyme we're focused on today is amylase. So, as carbohydrates enter the duodenum, okay, amylase comes in and it breaks these carbs down. When it breaks these carbs down, you have to know what carbs are made out of. Carbs' first functions are glucose, galactose, and fructose. Okay, those are the three building blocks, 3 amino acids of carbs. But amylase doesn't break them down to those singular ones. It breaks them down to branches of them or combinations. For example, we got maltose, and sucrose. Okay. This maltose and sucrose are not byproducts. They're combinations of those 3 building blocks. Okay. So we can't actually absorb these because they're not at the singlest amino acid form. So now we have what are these called again? Brush border cells. These are on the microvilli.
These are the microvilli.
These are the microvilli, and basically what brush border cells do is they release something called brush border enzymes. Brush border enzymes, the ones that we're going to focus on in our notes are maltase and sucrase. So, let's draw this here. They release maltase and sucrase. Now, if you look at maltase and sucrase, they look a lot like maltose and sucrose. Basically, maltose is glucose plus fructose, I'm pretty sure. I have to know that? Not really. Just know that maltase breaks down maltose from the brush border enzymes. And maltase is glucose plus fructose. So it literally breaks them down to glucose plus fructose. Okay? No, this is actually galactose. No, it's not. It is glucose. Glucose plus fructose. Okay? And now sucrose is glucose plus glucose. So if you're lost, basically, what I'm trying to say is carbohydrates came in from the stomach, and the amylase from the pancreas breaks them down to almost its simple form. It breaks them down to its combinations almost. So we got maltose and sucrose. It gets broken down from carbohydrates to maltose and sucrose. The brush border enzymes, also known as our microvilli, release brush border enzymes like maltase and sucrase, and these specific enzymes break its specific, I want to say its copy almost. It breaks down the specific carbohydrate. Another fact is when people are lactose, another byproduct of breaking down carbs are lactose, and sometimes people actually don't have lactase.
Like you, and that's why you shit your pants when you
That's
drink
me,
milk.
that's me. Some people like me don't have, our microvilli don't produce lactase to break down lactose. So the lactose ends up going through our small intestine and makes us shit. So basically, you just have to know that, review, we eat carbohydrates. There's 2 kinds. There's alpha and beta. We only have alpha, and beta is also known as fiber. Beta is literally just plants. Beta are plants carbohydrates, and alpha are more meat. So as we eat carbs, they come through. Nothing really happens in the stomach except gastrin being released. Gastrin tells parietal cells to release hydrochloric acid. Hydrochloric acid makes the bolus very acidic. And the acidity activates the C cells and the I cells to release secretin and CCK. Secretin tells the pancreas and the liver to release bicarbonate. Bicarbonate what it basically does is it raises the pH level. Why do we need the pH level raised? Because our digestive systems work the best at around 7 to 8, so a more neutral pH level. Also, CCK tells the pancreas to basically make more enzymes and release the enzymes. The 3 enzymes being lipase, amylase, and trypsin. Carbohydrates are broken down by amylase and pancreatic. Just so you know, pancreatic amylase is more potent. It's much stronger than the salivary amylase. So it breaks it down to a more molecular level. And those molecular levels, there are combinations of glucose, fructose, or galactose. 2 of them being maltose and sucrose. Our microvilli make microvilli enzymes, also known as brush border enzymes, and it makes an exact copy. So if there's maltose, the enzymes make maltase. If there's sucrose, our microvilli make sucrase. And those basically break them down to its fundamental copies, being maltase is glucose plus fructose, and sucrose being glucose plus glucose. And that makes it basically a singular amino acid or a monosaccharide. And it goes through our villi, into our hepatic portal, to our liver. And that's how we eat carbs.
Thank you, Professor Almer.
No problem, guys, no problem.